Support for today's Heat Treat Radio episode is provided by Heat Treat Consultants. Find the most comprehensive list of consultants in Heat Treat at www.heattreattoday.com/consultants. Welcome to Heat Treat Radio. Today, Doug Glenn, publisher of Heat Treat Today, and Dennis Beauchesne, general manager at ECM-USA, hash out the misperceptions about robotics from their realities for the heat treater. If you're looking to incorporate fascinating new tech onto the floor, you better take a listen.
Thanks for joining us. It's been a long time since we've talked about finally getting together on Heat Treat Radio to have a little conversation about some interesting things. Today, we're going to talk to Dennis Beauchesne, who I'm going to let Dennis introduce himself in just a moment. But we're going to talk to Dennis Beauchesne of ECM-USA a bit about robotics. But Dennis, welcome. Appreciate you joining us.
Well, Doug, thank you very much for having me on. And yes, we've been talking about it for quite a while.
Yes.
And I'm really glad we could finally get our schedules together to make this happen.
Yeah. So we're recording just after the holidays. I think both of us are sobered up. We're back to be able to think clearly. Do want to talk about robotics though. But let's talk just to give the listeners and or viewers a sense of Dennis Beauchesne, your background. Just briefly tell us where you've come from and how long you've been working in the North American heat treat market.
Right. So thank you. So my name is Dennis Beauchesne. I am the general manager of ECM-USA, which is the U.S. subsidiary of ECM Technologies, working out of France. And I've been with ECM Technologies for now almost 21 years. About 10 years before that, I also worked with other furnace companies and some in the heat treat business, as well as selling alloy baskets, fans, those kinds of things. Also had a rep organization for 3 years where I sold probes and a number of other heat treat related items, of course. So I've had my share of crawling around furnaces and heat treats and getting to know the applications, loading mechanisms, and all of the processes, or most of the processes. Certainly not an expert on a lot of the heat treat processes, but one in particular, low pressure vacuum carburizing, and especially with gas quenching, is something that I've been working with for over 20 years. But certainly hardening and other applications as well in vacuum furnaces is our forte. Yeah,
great. Now, and based on conversations you and I have had in the past, we started talking about robotics, right? It's almost an element of Industry 4.0 to a certain extent, augmented reality, virtual reality, things of that sort. Robotics definitely fits into that some. So let's talk about that a little bit. From your perspective, what is ECM seeing as far as just the use of robotics? I'm curious, just industry in general, but if you want to narrow it down also and talk a little bit about where are you currently seeing robotics used in heat treat, that would be great.
Sure. So robotics in general and automation has always been a leading technology for ECM-USA and ECM Technologies worldwide. A lot of our vacuum furnaces, as you know, are large scale, high production equipment, as well as single chamber systems. But automation usually plays a part in our offering, and that before was conveyors, walking beam tables, rolling tables, those kinds of things, where we automated the process so that you would have obviously time control over the process when the parts went to temper, et cetera. But what we're seeing more and more, and the reason that I'm here today is that ECM is very much involved with the robotics handling of parts before and after heat treatment as well. So we've come across quite a few applications in the industry where these are required. And also, as we know, you and I were just at some recent fall meetings, and labor availability is the number one issue in the world today, as we know. And I really feel that robotics can do a lot to help out in that area. And where we've seen robotics work is loading, unloading alloy fixtures, loading, unloading CFC fixtures. taking parts out of bins and putting them in heat treat fixtures. And then you either have operators move them to the furnaces or load them automatically through the automation system, conveyors, walking beams, et cetera. So we've done those systems, especially in Europe. We've done a number of systems there. We are installing a system here this summer in North America, and it will be fully robotic integrated. So the customer brings us parts that will be in particular totes, and we would be loading them into CFC fixtures. The fixtures will be retained in the heat treat area, and then the parts will be unloaded after heat treat and then loaded back into their particular bins, totes, and the containers. So a completely automated process. And it's not that it's the same part every time. There are actually 175 different parts. So I think that's a really important piece of information. And they're not all gears, they're not all shafts. There's a mixture of a bunch of different parts. So it's a very challenging application, but also one that with today's technology and robotics, vision systems, is a doable situation. And we're looking forward to showing off more of that.
Yeah, that was one of my questions, especially when you mentioned 175 different types of parts. Is the system that you're speaking about, or are the systems that can be made by ECM or others? I assume they are going to use vision recognition, right? They're not just going to say, well, I'm going to take my my robotic arm, and I'm going to this position where they tell me there is this type of part. Or is that arm actually going to be able to say, oh, that's that type of part, therefore I treat it thusly?
Yeah, there's, I would say in this application, if people saw the loading, unloading, they would say, well, of course, the part's going to be in the same location. It's going to be in the same tote. It's going to be in the same plastic locking device that it's going to be every time. So this is true, and this is very true in this application. And I think that's one of the things that's a challenge in the heat treat business is that parts come in, especially for heat treaters, not the captive operations, but even in captive operations, parts come in different forms. They're in bins, they're in tins, they're in bins with plywood covers, with cardboard covers, with bubble wrap, all the things that you see across the marketplace. And as you mentioned, vision is a big part of robotics. You actually have some eyes for the robot to know there's no part there. I'm not going to go get it. I change my program. I go here, or I twist the wrist of the robot a different way to pick up that part, whether it's flat or round or whatever. So there are vision plays a big part, and the advancements in vision and robotics are huge and have been huge, as they have been in vacuum furnace technology as well and gas quenching. So those things moving forward are a lot of part of research and development at ECM and ECM-USA. So things are moving forward. Okay, so before we get too deep into what exactly these robots are and how they work, I just still want to question you a little bit about the motivation for why people are using them. I mean, you mentioned about labor, right? Labor shortage being one of the main reasons. Is I'm assuming that there are some benefits there. Are these robots replacing people, or are they assisting people? What do you see? Yeah, I think it's really across the board for both. You are replacing people, but not really replacing people that aren't present. I mean, that's part of the labor shortage is you don't have people to replace. So that's part of the situation. So we're really adding to the capability or the versatility of that heat treat shop or captive heat treat by adding a robot or adding a person, if you want to look at it that way. But they're also working together with the people on the line or in the heat treat to assist them. So you could have a robot that merely lifts a bin and moves it to another location where you're helping a person not having to pick up such a heavy load. You also have robots that are placing parts precisely in a fixture or placing parts precisely in a bin. Whereas the quality of that part is not impaired. Like you're not dropping it or you're not scratching it along with another part. You're moving it very carefully, like a customer would want to handle that particular part with higher quality. I think what was best taken from one of our fall sessions was that I remember one of the presenters indicated they were using robots and said that in their process they were using this robot to actually do some of the heat treat. And they said that they really no longer can do that heat treat process anymore with a human because the robot was so precise at getting them heat correctly on that part for what they were doing. So in that way, you are increasing the quality and the value of your heat treat and your the robot integration.
Right. The repeatability is the issue and the real advantage there. Precise placement and processing of that item, which even the best of us humans can't do.
Exactly.
So, yeah. Okay. Good. So, realistically speaking, from ECM's perspective, can you give us a sense of what the growth in interest in robotics has been? I mean, let's maybe just take a snapshot. 10 years ago, what was it like? 5 years ago, what was it like? What is it today? I mean, what kind of growth are we seeing? What percentage of your RFQs are actually asking for it?
Yeah, that's a great question. I would say that 10 years ago, there were very few opportunities or very few discussions about robotics. We would have robotics discussions with, let's say, large automotive companies that were doing thousands of parts a week or a year. And they would mostly at that time talk to outside robotics companies and try to integrate robotics into a heat treat market, where a lot of robotics companies would say, you mean this surface is going to be warped? It's going to be changed the next time I go to put that same part in that same location? I can tell you that caused a lot of havoc in the heat treat business. Also, with just handling parts in and out of a heat treat load, whether it was a new heat treat load that was green or a heat treat load that was already hard, handling those parts differently, whether it's especially in a gas cleanse situation, knowing that they're been processed or not. That was also a new development in robotics. So 5 years ago, I would say you started seeing more people where there were several robotic companies that were out there that were starting to say, hey, we can handle this. Vision was coming along a lot faster, and there was more presence of vision in with the robotics. Today, I would say the last 18 months to 2 years, we've seen a real uptick in our RFQs coming in where they're looking to a company like ECM, where we have a lot of experience in automation, to further that arm to get robotics involved with not only just processing a load of parts, but taking apart single piece and then building a load and then processing that and then giving the piece part back to the operations. And that's been increasing quite a bit. And in an effort to take care of that, about 5 years ago, we had purchased a company that was doing a lot of robotics internally with their furnace systems in the semiconductor industry.
Okay.
And so we had a lot of robotic technical expertise in that. And if you know that industry, you're handling a lot of thin parts and a lot of movement, very high volume. And also there's a lot of vision that's being used in that, and also vision in the quality control as well afterwards. So today we're seeing requests for robots loading, unloading. We're also seeing requests for robots picking up parts, putting them in front of the camera, actually measuring the part for distortion control. We're also seeing parts that are being automatically hardness tested before they're put into the finish part bins or totes or wherever the next stage of processing is.
So I assume at that point at time they're able to separate the sheep from the goats, so to speak. Well hardened, not well hardened, and
exactly. Yeah, there's a lot more automated systems for those process quality control as well as the parts come out of the furnace.
Yeah. Okay. So let me ask you this question, because I'm curious. A lot of times when some people think of robots, we start thinking of the Jetsons or something like that. But I think most people with their feet on the ground, up their heads not in the clouds too much. When we think of robots, I tend to think of, that robotic arm, right? That type of thing, where it's a stationary robot, if you will, with functions, within its reach. Is this the type of robot we're talking about now? Is that what's most common, or do you anticipate that there's going to be those mobile robots that are roaming around doing things, helping with workers, or are they exoskeleton type robots that are on the backs of people? I'm just curious what your prognosticating is on that point.
Very, very good question again. I would say that when we look at robotics moving parts around the plant, we usually call those AGVs, or automatic guided vehicles. And we're working on a number of projects with those types of facilities. And that reduces a lot of traffic internally for people moving forklifts around, and it becomes a much safer facility.
And these are not on tracks, right? We're not talking, they're not like on monorails or railroad tracks. It's just free moving.
Yeah, tracks are a thing of the past now with AGVs. There are a number of different ways of doing it. I'm not an AGV specialist or robotic specialist for that matter, but they do have AGVs now that are controlled by cameras up in the plant, so that the cameras know exactly where the AGV is and is located. And there are also ways of putting tape down or some other line in the concrete where the AGV can follow. So those methods are out there for AGVs, and usually the AGVs are used in some of the situations we're into right now. They're used to promote the accurate tack time through the plant. So that's whether it's 20 minutes, they need a part every 20 minutes, they need a part every 10 minutes. It's well designed in that fashion. So there are usually tracks or pallets that are on these AGVs that move from machining center to heat treat center to post machining center, post heat treat center. So those things are very much out there. AGVs have also grown leaps and bounds as well in their own right. As far as the robot being stationary, or as you spoke about, working together with other operators in a collaborative fashion, both of these methods are being used, of course. But we still see that the larger single arm robots, let's say, can be multifaceted. In other words, we can have 3 or 4 handling devices, or grippers, as we would say, on the end of this robot. So it could be picking up a part, then picking up a tray, then picking up a full load with the same gripper or the same handset that's on the gripper. So these are multifaceted robots. So you're not really looking at every time you need to pick up a different part, you need to have a different tool. So that's what's being done with those, as well as trying to reduce the footprint and making a much safer robot system with the collaborative design, where if you touch it, it stops. In addition, robot programming also has become far less tedious, let's say, or far less required from a specific person to do the programming.
Right. And you mentioned the word I wanted to ask you about, which is probably the hot topic, and we'll have to make sure the lawyers get involved here. What about safety? I mean, especially, it's not just the stationary ones, or it's not just the mobile AGVs, I think you said, that afraid of running somebody over or hitting somebody or something, but it's also these stationary ones that have moving parts. Any safety concerns, or what can you tell us about the safety, the advances in safety, that type of stuff?
Well, of course, safety is always very, very important part. I mean, we're trying to eliminate workers by not having to pick up these parts and whatever, but we still need to be safe in that environment. So there are a number of ways. A lot of people are trying to get away from the full cages with light curtains and those kinds of things. So using the collaborative robots where they're touch sensitive and can be shut off instantaneously, are probably the best way to go. With the AGVs running through the plant, there are a number of sensor systems on those AGVs that would stop them, as well as they move at a very slow pace as well throughout the plant. But there are a number of safety devices, depending on the installation, whether it's a standalone system or it's something that working collaboratively with a person. Safety is always important and can be working. I would say much more advantageous these days with other workers.
When we return, Doug and Dennis are going to talk about limitations and hesitancies related to robotics and how they're mainly a matter of perception. We'll also look at real concrete benefits to implementing robotics. But first, are you looking to stop the brain drain at your heat treat facility? Turn to today's sponsor, Heat Treat Consultants, for a comprehensive list of heat treat industry consultants. Plug in www.heattreattoday.com/consultants to find experts that can help you manage better, heat treat better, or understand safety and tech solutions better. Details about each consultant are easily found when you click their name in the Heat Treat Consultants list. Contact a heat treat consultant directly or come to us so you can be introduced. Whether it's a technical process question, a safety concern, a compliance issue, or a business-related question, one of our heat treat consultants will be able to help. Again, heat treat consultants are at www.heattreattoday.com/consultants. Now, back to the episode.
I think the whole advantage here is that it's better. Ultimately, it's better for the human worker to have these machines doing it. I mean, it's taking away typically the robotics are taking away some of the redundant, the tedious work, that type of thing. Would you agree with that?
I agree. And that's typically what we discuss with the customers as where in your plant do you have difficulty hiring people to work? And I would say 90% of those customers answer, I can't hire anybody for a long period of time when they're taking a part from a bin and putting it in a fixture, taking a part out of the fixture and replacing it in the bin properly. They say that those people last a few months and they move on. The worst case is that if you have someone that's been there a long time and you put them in that position, it's a negative form. They finally feel like, okay, they've got something on me and I have to go down and build loads now. So, and I think that's really, like you said, people are thinking about robots and they're a little bit hesitant, but I would say that, and maybe you'll get to this question, but it's more of the possibilities and the way people think about robots. I would have to say the most that I've heard, especially from heat treaters, is, well, it's not going to do what I need it to do. I can't use a robot because I don't have that many of the same part every year. And really that is changing. What we're planning on doing is having a demo site here, hopefully before the end of this year, where we could have certain bins of parts and show how with vision we can pick up different parts and put them in heat treat loads and move them around. So yeah.
Well, let's go there. Because that actually was a question I wanted to ask. To a certain extent, we're limited in our willingness to use robotics because we're probably limited in our understanding of what they can do, right? And I'm quite sure that as much as ECM has dedicated resources to developing current capabilities, that I'm sure there are some dreamers in your group that say, we could get robots to do this if only someone would say, okay. Can you share with us maybe some of the things that you are currently doing that are kind of maybe a little cutting edge or at least useful to our captive heat treaters? And then also some of those things that could be done. These are some of the things. I'm just kind of curious to the extent of where we might be able to go here in the next 10 years.
Yeah. And I even myself learning as we go along as well of the technologies that are out there. I mean, what I'm impressed with robotics is they not only help once they're installed, but before the concept is even put together. I've put on VR glasses and walked through a heat treat, and you can understand exactly what the robot's function is, what it sees, where it goes. We can actually also walk through a furnace installation and see what the height of everything is, the level of everything, so how it moves around. So those are some of the applications even before you get the robot involved or installed. The other possibilities that people do think that, oh, this is going to be expensive, first of all. They think, well, it's not going to work on my parts in my situation. There will be some concessions that everybody's going to need to make. For instance, the heat treat fixtures, maybe the ones that are really warped, you're going to have to not use those as much anymore. Or you may have to go to more standard basket or a more standard fixture for all the parts. So you may not get your million parts in one load like everybody wants to get, but you would get them done more efficiently and faster as well. So some of the applications we've done where we've taken very thin ceramic material and put it on setters and put them in some brazing furnaces and sintering furnaces, and then move the loads around, unstack the load, stack the load, restack the load, and done that all completely in a robotic cell without touching the parts ever. And then as the parts come out, they're electrically tested to make sure they're good. And like I said, in this other application or several other applications, we've also done bulk filling of CFC fixtures. So you would have a CFC fixture that needed to be, say, bulk loaded with small pieces. We'd actually have them go through a vibrating machine, fill the CFC fixture to a certain level, the robot comes over, puts a screen on top, moves the CFC fixture onto a heat treat load, and does that continuously.
Is that done, Dennis, by weight or by vision?
Both, actually. By both.
Okay.
Yeah, both. Yeah, because you can have the weight, but you may not have it even.
Yeah, so it's got the distribution. They would vibrate it out till it's acceptable, and then the screen would come in. Okay, that's interesting.
Exactly. And like I said, the possibilities of heat treat robotics is really what it's coming down to. Heat treat robotics today is to educate and have everybody understand that it is and could be capable of taking flat parts out of bins and putting them in fixtures properly and removing them and doing the reverse action. That we need to educate people that these things are available out there, and it doesn't have to be at any particular type of furnace or any particular type of size of load of the furnace. It's a matter of setting up a station, maybe a loading unloading station that you might have an area in your plant to do the robotic handling of it. And with our expertise in heat treating, understanding the facets of what happens to the parts and the fixtures during the heat treat process. So those are the kinds of things that we see, like I said, right from design of the system and the layout, understanding how everything's going to work on a VR standpoint, all the way to implementation in a facility that takes in many different parts on a daily basis and processes them. So I think that's true to form in what's moving forward in robotics today.
Okay, so now here, let's just talk. I want to throw this one at you, see what your input is on this. Let's think about robotics for the whole way through a process. I want to think just for a minute about, let's just say a mesh belt furnace. I know you guys do a lot in vacuum and things of that sort, but could be the same type of thing. Could we use on the front end robotics to do not only placement of the product, but product inspection? Let's say making sure that it's a clean surface, because some of these, for nitriding, for example, making sure impurities are off and things of that sort. I assume we could use robotics on that end to inspect the product, make sure it's good to go in the basket. Then we put it in the basket or in the fixture, whatever, goes through the furnace, comes out the other end, is inspected at that time, right? Picked up, inspected for whether it be hardness or whatever, distortion, and then placed out onto the, depending on where it needs to go. I assume all that's possible, correct?
You assume, and yes, it is possible. I personally haven't seen anybody install that particular system, but I would love to be part of it. We have designed a system and quoted on a system that was used using a mesh belt. There's a very good example for you as well, where the customer felt, or actually the customer of the heat treat department felt that the parts, these were like coin-shaped type parts, and it felt better that the parts were run, that were processed better vertically, rather than just in a pile on the belt. So these parts were put in small fixtures on the belt, and this fixture was maybe 6 inches by 6 inches, and took up a 4 foot wide belt. And those were loaded in place very properly, and then also on the outside, on the outlet of the furnace belt, were also unloaded. And then, of course, they were also, or the design was for them to inspect them by coloration, and then also by hardness. So that was a real. And I didn't share that with you before this meeting, but that was one application that we quoted on, and yeah, it's really something that's very doable.
We talked earlier about the companies who, for example, if they have high diversity of product, right, and not high quantity of those products. I assume, and you've mentioned it, that really robotics probably is not as likely to be helpful to them as a company who has low variability of products but high volume of those products. Do you have any comments on that? Is that safe? For example, a commercial heat treater who does all kinds of crazy things, doesn't have a lot of any one thing. Safe to say robotics probably would not be as useful to them?
Well, I would have to say that is the thought that we're trying to change.
Okay, all right.
That's the thought that we're trying to change. We're trying to change that thought because I've sat at a number of the tables during the lunches and dinners at some of these presentations, and that's exactly what I hear from the heat treaters. Well, now robotics isn't for me. I don't do enough of the same part. And in reality, a lot of these robotic systems now are easily programmable by grabbing the gripper and moving it to where you want it to go. And if you have repeatable parts, like, okay, maybe you don't have 100 million of these parts in the same month, but maybe you have 10,000 of them over 12 months. So once that's programmed in the robot, then you have that program for the next time. So there may be some initial programming time that you may have to apply to it. And we don't see that is a big downside, because the vision system will understand what the part looks like before the robot picks it up. So the programming is become much easier and simpler for everybody, so that you don't have to have a big staff just to take care of the robots. And I think that's the other misnomer that companies have, is that, well, if I get a robot, I don't only have to pay for the robot, but I have to have the 5 support staff for that robot. And in fact, that's not something that's becoming a thing. I would say that in one of the cases, the same person that was talking about the quality of the robot was also talking about the excitement of his team to work with the robot, and to be able to learn to program that robot, and that being their job rather than loading and unloading the fixtures. And to them, that was more exciting and made them come to work. Wanted them to come to work every day, and also was a lead in for them to hire more people. To say, hey, we're implementing robotics in the plant, and there's an opportunity to work in that department eventually, or eventually we'll bring robotics into your department. So there are those incentives as well with some of the employees.
You may have hinted at this before. You're saying that programming of the robot sometimes can be as easy as showing it what to do by moving it, saying, here's what you do, grab this, put this here, grab this, put this here. That's as easy as it can be?
It's becoming that way, yes. I'm not a programmer, but I've seen a lot of demos, as a lot of other people have, that, yes, those things are possible. Get it in a general location, and then maybe you tweak it a little bit here and there. Yes, those things are much, much easier to do.
So probably to say to those who are robotic doubters, let's just say, that probably would be good to not assume that it's as difficult as what you might think, and to keep an open mind, right? Let me ask you this. So as let's say it could be a commercial heat treater, but let's talk about most of our audience, or a lot of our audience, are the manufacturers with their own in-house heat treat, right? So what we call captive heat treaters. What questions should they be asking themselves about robotics, or whether or not it makes sense for them? I mean, is there a list of questions that they ought to be asking or considering before they even say, yeah, we probably ought to consider robotics?
I think that when you're doing repetitive operations in your facilities, whether it's captive or heat treat shop, when you're doing repetitive operations, I think that's where you get the most benefit from a robotic system, obviously. So that's one thing. The other one is, are you doing similar operations in that repetitiveness? Like, are you always building the same type of fixture? Are you always building it for the same furnace load? Those things where you can get, I would say, the more similarities you can get to that robot to work with, the more cost effective it becomes. But there are also a lot of benefits to having that robot be very versatile in working with a number of different size furnace loads, as well as part dimensions. So I think I can't say that there's a specific set of questions, but certainly would love to work with any customer that has a thought of even a thought that, hey, maybe I should look into this. We'd be happy to talk to them.
I think the high repeatability is critical. I would imagine, Dennis, tell me what you think of this, that if they're dealing with high value parts, even if there's not a huge number of them, and they're looking to eliminate the potential for human error, even if it's simply in the placement of that product, or if they're looking for single part traceability, perhaps, robotic systems definitely, it seems to me, would be also something that would be of interest.
Yeah, absolutely. In-process defects, that's something that would be very good at eliminating. And also, as you said, if you were looking for traceability, I can tell you that we can build a robot system that can trace, even if you have 500 parts in a heat treat load, it can tell you exactly where the part came from in the load, where you put it in the load, where it came from, and where it went after it came off of the heat treat rack. So traceability is really a good point that I didn't bring up, but thank you for that, Doug. Because
add that to your list. Add that to the list.
Add it to my list. But yeah, traceability is really important as well, right? You can do that with the furnaces, and that's for a single piece part flow, whereas a lot of people are going to that method. A single piece gets to the heat treat furnace, not a bin of parts, and then you can trace every part through the heat treat load and back out of it.
The other thought I was having while you were talking was that and this may be a number of minor cases, but a lot of times there's situations where a part's got to come out of and of course this could be done with, I suppose, manipulators or things of that sort, but where a part's got to come out of a hot furnace, it's got to cool off in order to be moved to the next location, to the next process. Seems to me with any type of automation, robotics included, that you could eliminate the amount of heat loss between furnace one and temper furnace, the next process. So I don't know if that's a reasonable one too, but
yeah, I think that's another application is operating press quenches, where you're moving a hot pot out over the end of a furnace and moving it over to a quench. It's an extremely hot part that you don't want to touch. Obviously, there are gantry systems for that. There are a number of robot systems that can be installed to get those people out of those hazardous, jobs. For sure. Yeah, definitely a place, and also ensures the quality because your timing is really important as well.
Yeah, you mentioned about maintenance of these systems, or a little bit, at least the programming of them. I'm assuming maintenance is somewhat of an issue. I mean, if there's moving parts and things of that sort, there's probably going to be some maintenance on it, whether it be hardware maintenance and or software maintenance. Any comments on the amount of money or amount of time that a person would spend maintaining these systems as opposed to maintaining a human being doing those systems?
Well, it's a very good question. Again, And it should be something that's part of your machine maintenance, whether it is a machine tool, it is going to need some maintenance. So it's part of your maintenance requirements. So if people use the same maintenance priorities that they do for their heat treat furnaces, thank goodness the robots work really well as well in those hazardous environments. So I would say that they hold up very well. Robots have been around a number of years, and they're very industrialized. So maintenance is not as critical as they used to be, but obviously still required.
And I'm sure they can handle the environments too, whether hopefully the environments in the heat treat shops are getting better, not so smoky, oily, that type of thing. I'm assuming that any robots you put in there would be able to handle whatever environment it's in. So that's good.
That would be part of the requirements as well.
Yeah, exactly. Okay. Any concluding thoughts? Anything I've missed that you want to hit on at all, Dennis?
No, I just think that when you think, robotics isn't for me, spend a little time and look into it. That's really my. I've been blown away with the technology to today. I mean, look at our cell phones aren't even phones anymore. We use them for many more things than we use for a phone. Robotics have come to be that way as well. There's so many more things that can be used in conjunction with the robotics to help you get your job done and service your customer, appropriately with good quality parts.
Yeah, I got one other quick question I just thought of. So often we perceive, at least I perceive, let me own this one as opposed to blame others for it, right? I perceive that a lot of times companies in Europe are a bit ahead of us on technology, or at least the adoption of some of these technologies. So with ECM being, the mothership being in France, are you seeing that there's a wider acceptance of robotics from companies in Europe than here in the States?
I wouldn't call it acceptance, but there are many more applications and customers looking into it in Europe than there are here. Yes. I think that maybe we haven't realized that the people aren't there and we're not going to find them. Then I think in Europe, where they realized even a few years ago that they're just not going to find these people, and they need to automate, or the operators that they can find are not going to get the job done the way they needed to get it done, because technology has grown so fast with the quality of the parts necessary, especially with EV products today. Dropping a part or having a part nicked by something, or even continuous productivity is important. So yes, we've seen more in Europe, and that's another reason why we've been on the leading edge of this technology, and now bringing it to the U.S. And North America is in a more simpler fashion, with the same people having the same experiences over in Europe. Yeah,
and being somewhat facetious, the other thing robots give you that humans don't is they don't have to pass drug tests. I'm pretty sure that the robots are okay.
They don't have to pass drug tests, and they don't have to get COVID tests either. So,
yeah, good point. And they don't miss many days of work, but nonetheless. All right. Tell us what you're comfortable with as far as giving out, any of your information for us to get in, for not us, but for listeners to get in touch with you.
Sure. You can go to ECM-USA.com. You can fill out a request form there. You can email me directly, my full name, Dennis Beauchesne, or db@ecm-usa.com. You can call my cell phone, even 336-210-5316. We'd be glad to talk to you about any of your potential applications. You're kicking it around, you're thinking about it. And we have some information on our website and on the ECM Technologies website in France as well on robotics. So those are the places that we can get contact.
Great. Dennis, thanks a lot. Appreciate it. Good to talk with you.
Same here, Doug. Great to see you, and great to talk with you. It's a great subject, and I appreciate the questions, the input, and the coverage.
We hope you enjoyed listening to today's episode with Dennis Beauchesne. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with Dennis, head over to www.ecm-USA.com or call him at 336-210-5316. You can also either email him at db@ecm-usa.com or reach out to me and I can put you in touch. My email is bethany@heattreattoday.com. Do you have a new or interesting idea that you want to hear discussed on Heat Treat Radio? If so, let me know. Also, if you'd like to sponsor a future episode, let me know at bethany@heattreattoday.com. Heat Treat Radio is just one way Heat Treat Today tries to help you get the information you need to make good decisions. If you like what you heard, explore the e-newsletters, ebooks, social media groups, and more that heattreattoday.com has to offer. Heat Treat Radio would like to thank Heat Treat Consultants for sponsoring this episode. Find the most comprehensive list of consultants in Heat Treat at www.heattreattoday.com/consultants. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Our amazing audio and visual producer, Jonathan Lloyd, created and mixed most of the music that you heard today. Check out his professional work at www.jonathanlloydmusic.com. Thank you, Jonathan. And I'm your host, Bethany Leon. Thank you for listening.